Hi, dear children. Welcome to another live session of physics from Brilliant YouTube channel. Hope your preparations are going good. You know that exams are very close to us, so each and every minute are important. Please practice as many questions as possible. Focus on the concepts. So in today's session, we are going to discuss another important chapter, that is alternating current. In the last physics session, we have discussed electromagnetic induction, so hope you are perfectly okay with those chapters. So in today's session, another important chapter, alternating current, we are going to discuss. So I'm expecting your kind attention and quick response to each and every question. Comment your answers in the chat window within the short time and the quick time. So without wasting time, I'm going to the first question. Look at this. First question is, in LCR circuit, in the state of resonance, which of the following statement is correct? Cos phi is equal to. In LCR circuit, my dear children, you know that in this chapter the core topic is LCR circuit only, series LCR circuit. There are a lot of scopes for question from that topic. Now what they are asking, in LCR circuit at the state of resonance, which of the following statement is correct? Cos phi is equal to. If you know the answer, please comment it. Let's go to the discussion. Cos phi. What is phi in this equation? You know that phi is the phase difference, the phase angle, right? So equation for phase angle in an LCR circuit, you know that phi is equal to tan inverse of. There are two important formula. One is for the impedance and other is for the phase angle. Tan inverse of XL minus XC by what? R. This is the basic equation for phase angle. Now you know that at resonance, very important point, resonance means you know that current and voltage are in same phase. You know that condition very well. So current and voltage are in same phase means in this equation phi is the phase difference between current and voltage. So current and voltage are in same phase means what is the value of phi at resonance? So you know that at resonance phi is equal to 0. So in this question they are asking what is the value of cos phi? Very simple. So cos phi means cos 0. What is cos 0? Cos 0 is equal to 1. So which is our right answer? Very simple question. The right answer is option 1. So I'm getting the right answer from many students. Very good. Keep on doing it. So the answer for the question is 1. All right. So I'm going to the next question. Again, please note that resonance is a very important point in series LCR circuit. Question number 2. Again, LCR circuit question. Check it. In an LCR circuit, impedance is minimum when? Impedance is minimum when? You can answer it quickly. Impedance. What is impedance? The total resistance offered by the all circuit element together is called what? The impedance. What is the formula for impedance of a series LCR circuit? You know that impedance is represented by the letter A. So Z is equal to root of R square plus XL minus XC the whole square. What is XL? XL is inductive reactance, XC is capacitive reactance. So impedance is minimum. You know the condition again. Impedance will be minimum at resonance. What is resonance condition? XL is equal to XC. So if XL is equal to XC, this term will be 0. So what will be the result? Z is equal to root of R square. What is root of R square? It is R. So we got the answer. At impedance, impedance is minimum when R is equal to ZS. Very good. Karthik, Sanna, Dhruvil, right answer. Keep it up. So impedance is minimum means R is equal to Z. Okay, so I am going to the next question. Question number 3. In a pure inductor circuit, what is the angle between voltage and current? I don't think it need much time. You can answer it in 1 second. In a pure inductor circuit, what is the phase angle between voltage and current? We have 3 basic circuits. First one is resistor only. In a resistor only circuit, what is the phase angle, phase difference between current and voltage? Yes, it is 0. In resistor only circuit, current and voltage are in same phase. In a pure inductor circuit, in an inductor only circuit, if you remember, voltage leads the current by pi by 2. In capacitor only circuit, voltage is lagging. That means current is leading by pi by 2. So here they are asking just the phase difference. What is the answer? Pi by 2, 90 degree. Isn't it? Yes. So the answer for this question is option C, pi by 2. How many of you got the right answer? Yes, very good. All the students are answering. So I'm very happy with your response. So I'm going to the next. Keep going. Next one, question number 4. Yes, another important topic from this chapter, transformer. Okay. A transformer having 2100 turns in the primary and 4200 turns in the secondary has an AC source of 120 volt 10 ampere connected to its primary. Then the secondary voltage and current are. Take a paper, take a pen, start doing a calculation. Those who have doubt, listen here. Look, transformer. You know what is a transformer? Transformer is a device which is used to increase or decrease AC voltage. Yes, and you know the working principle, it is mutual induction, and we have some formulas. Very important but easy formulas. First one is we have a transformer ratio. What is that ratio? It is Vs by Vp is equal to Ns by Np. Ns by Np. This is the formula relating voltage and number of turns. You know very well Vs is the secondary voltage across the secondary coil. Vp is the primary voltage across the primary. Ns number of turns in secondary. Np is number of turns in primary. Okay, now here they are asking a transformer is having 2100 turns in the primary. That means Np is given. Np is 2100 and Ns is 4200. Number of turns in secondary. Source of it is connected to a source of 120 voltage. That means this is the input voltage, so we can take it as Vp. Primary voltage is Vp and primary current is also given. Ip is given 10 ampere. The secondary voltage and current. So secondary voltage and current they are asking. So from this equation you can easily find secondary voltage. So what is secondary voltage? Vs is equal to Ns by Np into primary voltage Vp. Substitute. What is Ns, number of turns in secondary? You can see it is 4200. Np, number of turns in primary, 2100 into Vp. Voltage, primary voltage is 120. So we got the answers. See, 42 by 21 is 2. 2 into 120, 240. 240 volt is the primary voltage. I can see the answers like option A, option C. Okay, we'll check. Anyway, secondary voltage is 240. Now we have to find what? Secondary current. There is a chance of confusion about secondary current. See, in this question, they did not say anything about the efficiency of this transformer. You know what is efficiency? Efficiency is the ratio of output power to the input power, and you are okay with it. You have clear idea about the transformer losses. Normally, practically, there will be losses for a transformer, which means output power will be always less than what? The input power. That means the efficiency will be less than 100%. But here in this question, they did not say anything about the losses, means you can neglect the power loss. If you are neglecting the power loss, we can write an equation how input power is equal to output power. That means P in is equal to P out if there is no loss. What is P input? Vp Ip. P out is what? Vs Is. Okay, so we have to find Is value, secondary current. So from this what you can write? Is is equal to Vp Ip by Vs. One method. Or directly you can write, if efficiency is 100%, the same transformer ratio you can equate with Ip by Is. So any formula you can use, either Ns by Np equal to Ip by S. So I am going with this only. We have to find Is value. Okay, so what is Ns by Np? Ns by Np value already we got 2. So 2 is equal to Ip by Is. So Is will be Ip by 2. What is Ip value? Primary current is given as 10 ampere. So 10 by 2, it's 5 ampere. Okay, so 240 volt is the secondary voltage and 5 ampere is the secondary current. S. Kaushik, very good. The option is A, 240 volt and 5 ampere. My dear students, there are two options with 240 volt. So please don't go with the option C. Here the answer is option A. I think it's clear for all of you. If any doubt, you can ask in the Comment box. Yes. Can I go to the next? Next question number. So transformer is a very important topic, my dear students. Please study the transformer ratio. Vs by Vp equal to Ns by Np. If efficiency is 100%, which means if there is no loss, you can equate that with Ip by Is, primary current to secondary current. Okay. Next. Question number 5. An AC ammeter reads the current I ampere. What is the peak value of current? Very simple question. An AC ammeter reads current of I ampere, then what is the peak value of current? You have to understand, if you are connecting an ammeter, AC ammeter, it will read the effective value of current. Effective value of AC. You know what is effective value of AC? Effective value is nothing but RMS value of AC. So here I ampere is nothing but RMS value. Okay, so IRMS is equal to I in this question. Now I think you can easily answer this. Yes, I can see that many students comment B as the answer. Let me check. IRMS is equal to I. They are asking peak value. Peak value is what? Peak value is represented by I naught. You know that IRMS is equal to I naught by root 2. So peak value I naught is equal to root 2 times I. Root 2 times I. Very good. Yes. Faris. Kevin. Correct answers. The answer is option B. Root 2 times I is the peak value. Clear? Yes. Easy question. I am going to the next question, number 6. Again a transformer question. Be ready. 220 volt is changed to 22,000 volt through a step-up transformer. The current in primary is 5 ampere. What is the current in secondary? So here number of turns is given. Sorry, input voltage and output voltage are given. You have to find the output secondary current. Again, here also in this question also you can take, there is no power loss. That means efficiency is 100%. So what is the formula? If efficiency is 100%, what we can write? Vs by Vp is equal to Ip by Is. Ip by Is, you can comment your answers, calculate it quickly. Ip by Is. So what we have to find? The current in secondary. Current in secondary means Is. So Is will be equal to, what we can write? Ip into Vp by Vs. Okay, so what is Ip? Ip is given as 5 ampere into Vp. Primary voltage is 220 divided by VSS, 22,000. Quickly answer this. As I can see, C and D both options are. Please check, don't make mistake. So 22 we can cancel 10 by, and this will also be cancelled, 5 by 100. 5 by 100, which is equal to what? 0.05 ampere is the right answer. 0.05, option C. Yes, Nitin, Sana, Fahad, very good, right answer, option C. 0.05 ampere. My dear students, please don't make calculation mistake in transformer question, because you're lucky if they're asking questions like this. There is no complicated calculation, so please be careful. Right, so the answer is option C. I'm going to the next question, question number 7. Check it. The ratio of secondary to primary turns is 9:4. If the power input is P, what will be the ratio of power output to power input? Neglect all losses. I'm not going to solve this question. I'm expecting the right answer from your side. I'm waiting. Please. Ratio of output power to the input power. The turns ratio is 9:4. Comment your answers. Output power to the input power. Make it fast. I can see option A, option A. Others also make it fast. Output power to input power of this question. Yes, I think so far the answers which I got is Fahad, very good. That is the right answer. Yes. My dear children, it is option D. Why? Please note that it is given that neglect all losses. It is clearly mentioned in the question, neglect all losses. If you are neglecting all the losses, you know that output power is equal to input power. So if input power is equal to output power, what will be the ratio? The ratio will be 1:1. Please be careful, okay? Yes, I think it's clear for those who made mistake. Input power is equal to output power if you are neglecting all the losses. Can I go to the next question? Yes, question number 8. Look at this. The power factor in an AC series LR circuit. What is the power factor in a series LR circuit? Power factor, it's an important topic. So let's quickly recall the concepts. Power factor, what is power factor? We know the formula for the average power of an AC circuit. What is it? P average is equal to VRMS IRMS cos phi. This is the formula for the average power of a series LCR circuit or AC circuit in general. So VRMS IRMS into cos phi. VRMS RMS value of voltage, IRMS RMS value of current into cos phi. You know that here the power is determined by the cos function, and that cos function is known as what? The power factor. Cos phi is called the power factor, but in this question it is not an LCR circuit, it is an LR circuit. How can you find power factor? One, if you know the value of phi, you can easily find cos phi. But there is another formula for finding power factor. Do you remember? Cos phi is equal to, in an AC circuit, let me draw the phasor diagram to make you understand. Let it be the phasor diagram of a series LCR circuit. You know that this is VR, voltage across resistor. This is VL, voltage across inductor, and I am taking VC here. So here you can see that we are taking an assumption that VL is greater than VC, and we found the resultant voltage. This was VL minus VC. I hope all are familiar with this phasor diagram. This is our resultant voltage V. And what is phi? Phi is the phase difference between current and voltage. This is current and this is voltage. So this is the phase angle, phi. Okay, so cos phi only we have to find. Power factor is cos phi. So from this one, what we can write? Cos phi is, you know that it is adjacent side by hypotenuse. So what we can write? Cos phi is equal to VR, adjacent side, by hypotenuse is V. V is the resultant voltage. What is VR? It is voltage across resistor. We can write it as I into R. What is V? Resultant voltage. Resultant voltage is current into impedance. So I will be cancelled. My dear students, please note this formula. R by Z. R by Z is an expression for what? Power factor of an AC circuit. R by Z. Okay. Now you can check the question. It is an LR circuit, so please don't be confused. We may be studying R only, L only, C only. After that, what we studied is LCR, but they can ask LR circuit, CR circuit, anything. That's very simple. So this is an LR circuit. So cos phi, power factor, what we can write? Cos phi is equal to R by Z. R by Z. What is impedance of an LR circuit? Impedance of LCR circuit is root of R square plus L omega minus 1 by Z omega the whole square. This is the impedance of what? LCR. So if they are asking LR circuit, very simple, just cut the term with C, because C is not there in the circuit. So if you are cutting C, this term will not be there. That term including capacitance part will go. So we get root of R square plus what? L omega the whole square. This is Z value. Now we can substitute here. R by Z is root of R square plus L omega the whole square. This is the answer, right? There are two options, same, C and D. So hope you understand. The right answer is either you can, now you can mark either C or D, but it won't be like that in the board exam. There will be only one option correct. Yes, clear, I think, for all of you. So I am going to the next question. So please note the formula. Power factor, we have a direct formula, cos phi is equal to R by Z. Resistance by impedance will give you what? The power factor. Okay, now I'm going to the next question. Question number 9. Look at this. Which of the following curves correctly represents the variation of capacitive reactance with frequency? Please answer this. Capacitive reactance with frequency. How capacitive reactance is related to frequency? Which graph is showing it correctly? Please comment your answer. It's an easy question. You know that we have 3 circuits element. They can ask graphical question based on anyone, either resistance, capacitor or inductor. Yes, right answer. Very good. First, resistor only. You know that in a resistor only circuit, what is the total resistance? It's R only. And it is independent of frequency. So in resistor only circuit, the shape of the graph will be like this. It is independent of frequency. Whichever frequency it has, the graph will be like this. And L only circuit, you know that the reactance is L omega. L omega means L into omega is 2 pi nu. So clearly you can see that this reactance is directly proportional to the frequency. So in the same question, instead of capacitive reactance, if the question is inductive reactance, the shape of the graph will be like this because it is directly proportional. But this one, in this case, it is capacitance circuit. What is capacitive reactance? Xc is equal to 1 by C omega, which is 1 by C into 2 pi nu. All of you know that from this, capacitive reactance is inversely proportional to the frequency. So inversely proportional relation, you can easily understand which graph is showing inversely proportional relation. It is option D. D is our right answer. Yes. I think it's clear. Yes. Joel, hope it is very clear for you. So I'm going to the next question. Question number 10. Again, an easy question. Power factor is 1, 4. For which of the circuit element the power factor is 1? Power factor is 1 means cos phi is equal to 1. Cos phi is equal to 1. So for cos phi to be 1, you know that phi should be 0. Phi 0 means current and voltage are in same phase. So you have to check and say in which circuit element current and voltage are in same phase. Surely it is resistor only. Very good. So the answer is a pure resistor. In a pure resistive circuit only, current and voltage are in same phase. The power factor will be 1. Yes, very good. I'm going to the next question. Question number 11. Look at this. The shown circuit has resistance-less chalk coil L and a resistance R. The voltages across R and L are shown. The virtual value of the applied voltage is virtual value of applied voltage, which means the effective RMS value only they are asking. How can we find it? It is which circuit? It is an LR circuit. LR circuit, it is inductor and resistor. How do we find the effective value? The virtual value of voltage. We have a formula in series LCR circuit. After drawing the phasor diagram, we got a formula like this. Resultant voltage V is equal to root of VR square plus VL minus VC the whole square. This is the formula for the resultant voltage. This is for LCR circuit, you know that. Now if they may ask LR circuit or CR circuit, that we can find easily from this. LR means you can skip the term VC. So the result will be V is equal to what? Root of VR square plus VL square. What is VR? Voltage across resistor. What is VL? Voltage across inductor. You can see that this is the voltage across resistor, 120 volt. This is the voltage across inductor, 160 volts. You can directly apply to this formula and tell me the answer, all of you, please. V is equal to root of, do the calculation, VR 120 square plus VL 160 square. Quick. Yes, Fahad. Right answer. Others also, please make it fast. 120 square, you can calculate it. 144. 12 square is 144. There will be 2 more zeros. 256. 2 more zeros. Okay, so 144 plus 256 will be 400. plus 2 more zeros. So what is the answer? 40,000. It will be 200 volt. So the right answer for this question is 200 volt. 200 volt is our right answer. Option B. Option B. Is it clear or not? So this is also a repeating type question. They will ask the effective voltage. So LCR circuit means this is a formula, VR square plus VL minus VC the whole square. Yes. Right. So I am going to the next question now. Yeah, again a question like that. Check the circuit carefully. In the circuit shown below, what will be the reading of the voltmeter V3 and ammeter A? Voltmeter V3 and ammeter A. Please check the question carefully, all of you. Voltmeter V1 is connected across the inductor. You can see that V1 is connected across the inductor here. V2 is connected across the capacitor. V3 is connected across the resistor. That only they are asking what is the voltage across the resistor. And apart from that, they are asking current also. What is the ammeter reading? Means we have to find the total current, right? Can you answer me? Quick. So here we can note a very interesting point and an important point. You can see that V1 is 300 volt. V2 is also what? 300 volt. What does it mean? Voltage across inductor is equal to voltage across capacitor. My dear students, if VL is equal to VC, it is nothing but the resonance condition, isn't it? VL is equal to VC means it is the resonance condition. So at resonance condition, what is the formula for voltage? V is equal to root of VR square plus VL minus VC the whole square. What you can see here, VL is equal to VC. That means we get V equal to VR. So voltage across the resistor is nothing but V, the applied voltage. What is the applied voltage? It is 220 only. Okay, so 220 is the applied voltage. So we got the voltage value. Now they are asking what? Current also. Very simple. I equal to V by Z. But it is at resonance. Resonance means Z will be equal to R. Substitute. V is how much? 220. 220 divided by what is the resistance value? 100. So it will be 2.2. 2.2 ampere. We got the answer very easily. Yes, very good. Right answer. Nitin, Reshma, Fahad. Yes. 220 volt is the voltmeter reading and the current will be 2.2 ampere. 2.2 ampere. This is the answer. Okay. So please be careful. If such question comes, first you have to check the possibility of resonance, whether VL is equal to VC or not. If VL is equal to VC, the calculations will be very simple. Okay, now I'm going to the next question, question number 13. Again a transformer question. In a step-up transformer, the turns ratio is 1:10. A resistance of 200 ohm is connected across the secondary, is drawing a current of 0.5 ampere. What is the primary voltage and current? Take pen, do it. Do the calculation quickly. Don't make mistake. Turns ratio is 1:10. So turns ratio means we can see that it's a step-up transformer. So NP by NS, number of turns in primary to number of turns in secondary is 1/10, 1:10. Okay, a resistance of 200 ohm is connected across a secondary drawing a current of 0.5 ampere. So what you can understand, I across secondary, IS is equal to 0.5 ampere. Secondary current is given. A resistance of 200 ohm is connected across a secondary only. So resistance in secondary coil is 200 ohm. And the current is given. So we can easily find voltage across secondary because V is equal to I into R. So IS into R we can write. So what is IS? 0.5 and resistance is 200 ohm. So what we get? 100 volt is Vs. Secondary voltage is 100, but they are asking primary voltage and current. Primary voltage and current. So we got the Vs value. So primary voltage now we can easily find because we know that Ns by Np is equal to what? Vs by Vp, transformer ratio. So Vp is equal to what we can write? Np by Ns into Vs. Np by Ns is 1/10, it's given 1/10 into, we found the secondary voltage here, it is 100. So what is the answer? 100 by 10 is equal to 10 volt. 10 volt. Okay. Right. So 10 volt is the primary voltage. In this question, actually no need to do the second part, because you can see that there is only one option with 10 volt. So we can directly mark it. But anyway, we are going to find the other part also. What they are asking? Primary current. Primary current. How can we find the primary current? IS is, we know IS value is 0.5. So again we can use the relation NS by NP is equal to what? IP by IS. Okay, efficiency we can take 100% because they did not say anything about the power loss. So IP will be what? IP only we have to find. It is NS by NP into IS. NP by NS is 1 by 10, so NS by NP will be 10 into IS. What is IS? Secondary current is 0.5, so 10 into 0.5. So we get 5 ampere. 5 ampere. So primary voltage is 10 volt and primary current is 5 ampere. So the answer is option B. So you can see that there are many questions from transformer and LCR circuit. Those are the core area of this chapter. So I am going to the next top question, question number 14. Again an easy question. If the instantaneous current in a circuit is given by I is equal to 2 cos omega t plus 5 amperes, the RMS value of current is. I think you guys can easily answer this. Make it fast. Instantaneous current I is equal to 2 cos omega t plus 5. 2 cos omega t plus 5 is the instantaneous current. Then what is the RMS value of current? Yes, you know that if you are comparing with the standard formula, it is I naught cos omega t plus 5. Which means from this equation you can easily write I naught is equal to 2. See, I naught is equal to 2. Peak value of current is given. But they are asking the RMS value. You know that IRMS is equal to I naught by root 2. What is I naught? I naught is 2. So 2 by root 2. 2 by root 2 is equal to root 2. So what is the answer? Root 2 ampere. Option B. Yes, option B is the right answer. Very good. Yes. Root 2 ampere. Okay. Going to the next question number 15. Yes. The RMS value of AC of 50 Hertz is 10 ampere. The time taken by an alternating current in reaching from 0 to maximum value and the peak value of current. So we need to find two answers. One is what? The time taken by an alternating current in reaching from 0 to maximum value. What is that? Time taken to reach from 0 to maximum. So just check, just recall the graphical representation of alternating current. You know that the graph of AC is like this. Voltage or current which is starting from 0, and you can see that it increases to maximum in one direction. It decreases to 0, and at this point it changes its direction and increases to maximum in that direction, and then again come back to what? 0. And this complete set of variation, what we are calling it, it is known as one cycle of AC, right? Yes, all of you know that this is called one cycle of AC. Now what is the question here? The time taken by an alternating current in reaching from 0 to maximum value. That means if we are starting from here, this point 0 to maximum, what is the time taken for it? Okay, there is a simple technique, you know that total time, we are calling it as a time period T. So half at this point, you know that it will be T by 2. That means at this point it will be T by 4. So the time taken will be equal to small t, if you are taking that as a time taken by the current to reach its maximum value, then that T is equal to what? T by 4. Clear? But how to find that? Check. Frequency is given as 50 Hertz. Frequency is, you know that it is reciprocal of what? Time period. That means 1 by T is equal to what? 50. So T is equal to 1 by 50. Substitute what we get, 1 by 50 into 4. So what will be the answer? So 1 by 200. So it will be, you can write 1 by 2 into 10 to the power minus 2. 0.5 into 10 to the power minus 2, which is 5 into 10 to the power minus 3 second. This is the answer for the first one. 5 into 10 to the power minus 3 seconds. Is it clear? Yes, 5 into 10 to the power minus 3 second. Now, but there are two options with the same answer. You can see 5 into 10 to the power minus 3, option C and option D. What about the other thing? Second question is what? The peak value of current. That's easy, because check the question again. RMS value is given as 10 ampere. IRMS is equal to 10. Then what will be I naught? IRMS is equal to I naught by root 2 equal to 10. So I naught is equal to 10 into root 2. 10 root 2. What is the value of root 2? Root 2 is 1.41, right? So 10 into 1.41. So we get 14.1. Yeah, got the answer. So the first one is 5 into 10 to the power minus 3 seconds, and the RMS value of, peak value of current is 14.14 ampere. So the right answer is option D. If any doubt, you can ask me. Yes, I can see the right comments from many students. Very good. So I'm going to the next. Is it clear? The time. So if they're asking time taken to complete half cycle, means it will be T by 2. So in any way they can ask a question. So please note this point. Next, question number 16. An alternating voltage is connected in series with a resistance R and an inductance L. If the potential drop across the resistance is 200 volt and across the inductance is 150 volt, the applied voltage is. Again a direct question only. I hope you remember we have discussed an identical question. V across R, VR, potential drop across the resistor, it is given as 200 volt. And across the inductance, VL, is 150 volt. And it is an LR circuit, series connection of R and L. So which formula you can use directly? In an LR circuit, V is equal to root of VR square plus VL square. So simple mathematical calculation. Please comment your answers quickly. Root of VR, voltage across resistor, 200 square plus 150 square. Comment your answers. Plus 150. Sorry, 225 will come. It is 15 square. So what will be the total? Yes, it will be 625,000 will come. So the answer will be 250. Very good. The square root of this will be 250 volt. You know that root of 625 is 25. So that simple calculation only we are going to apply here. Yes. Very good, Dhruval, Nitin. I'm going to the next question. I think it's very clear for you. Question number 17. Yes. An AC circuit using an inductor and a capacitor in series has a maximum current. If L is equal to 0.5 Henry and C is equal to 8 microfarad, then the angular frequency of input AC voltage will be. Please note, this is which circuit? AC circuit using an inductor and a capacitor. That means no resistor is there. Only inductor and capacitor. L and C are there. LC circuit in series has a maximum current. The current is maximum in such a circuit. If L is equal to L and C value are given, then the angular frequency, it's omega. You know that angular frequency is omega. So we have to find the value of omega, but this is an which circuit? LC circuit. So we know the impedance of an LCR circuit is what? Root of R square plus XL minus XC the whole square. So what will be the total impedance of LC? LC circuit will be only XL minus XC only, right? XL minus XC. So current is maximum. For current to be maximum, impedance should be minimum. Impedance should be 0 because there is no R. So impedance is 0 means, what is the condition for that? XL should be equal to XC. XL is equal to XC. XL is equal to XC means XL is what? L omega. XC is 1 by Z omega. Okay. So omega square is equal to 1 by LZ. From this we have to find the value of omega. So substitute 1 by, what is L? L is 0.5. Okay. And C is 8 microfarad. So it is 8 into 10 to the power minus 6. So what we get? That minus 6 will go up. We get 10 raised to 6. 8 into 0.5 is 4. This is omega square. Okay. So what will be omega then? Omega is equal to square root of this. So when you are finding square root, 10 raised to 3 and it is divided by 2. So what we get? 0.5 into 10 to the power 3, which is how much? 500. Yes, 500 is the answer. It's option A. Very good. Reshma, Nitin and Fahad. Yes, very good. The right answer is 500. It is option A. So please note that it is an LC circuit. In an LC circuit, impedance is minimum. The current is maximum means impedance is minimum. The condition is XL is equal to XC, or in other words, XL minus X is equal to 0. We are substituting that. Yes, I am going to the next question now. Question number 18. Yes, look at this. In an LCR circuit, the value of L is 0.4 by pi Henry and the value of R is 30 ohm. If in the circuit an alternating EMF of 200 volt 50 cycles per second is connected, the impedance of the circuit and current will be. Impedance only they are asking, but you can see that in the question it is started with it is an LCR circuit, but they did not give the value of C. So leave it, neglect it. You can consider it as an LR circuit. So what we have to find is the impedance of this circuit. How? What is the formula? For LR circuit, we can cut the term capacitance part. So we get Z is equal to root of R square plus XL. That means L omega the whole square. This is the value of what? Impedance. Now we can substitute the values. Root of, all of you do your calculation and tell me the answer. R is 30, so 30 square plus L omega. L is 0.4 by pi. This is L. Omega is not given, but you can see that 50 cycles per second. Cycles per second is hertz only. So 50 cycle per second is the frequency. So frequency nu is equal to 50. So omega is equal to 2 pi nu. So what we get? 100 pi. 100 pi is omega value. Substitute that value here. So 0.4 by pi into what? 100 pi whole square will come. Okay. So we get root of 30 square is 900 plus 0.4 into 100 will be 40. 40 square is 1600. So what is our answer? Root of 2500, which is equal to 50. 50 ohm is the impedance. 50 ohm is the impedance. Again you can see there is only one option. Yes, with 50 ohm, which means our answer is anyway it is option D. But before marking that, let us calculate the current also. Current I equal to, how can you find current? V by Z. Very simple calculation. V is given in the question, it is 200 volt. So 200 divided by Z. What is the Z value we calculated here? It's 50. So 200 by 50 is equal to what? 4 ampere. Got the answer. 50 ohm is the impedance and 4 ampere is the current, which means the right answer is option D. Option D is the right answer. Yes, very good, Fahad. So I'm going to the next question. I think it's very clear. So just impedance formula we are directly applying. Yeah, question number 19. Again, transformer question. A step-up transformer is used on a 120 volt line to provide a potential difference of 2400 volt. If the primary coil has 75 turns, the number of turns in the secondary coil. It's a very simple question, right? You can see that step-up transformer used on a 120 volt line, which means what? VP, the primary voltage. Primary voltage is equal to 120. Okay? And VSS 2400, secondary voltage. Primary NP, number of turns in primary is given as 75. What is NS? Directly you can use what? The transformer ratio, NS by NP is equal to VS by VP. No confusion, NS is equal to VS by VP into what? NP. VS 2400, VP 120, NP 75. So 20 into what? 75. The answer is 1500. Yes, option C. Very good. Very good. Very good. Sriram, Nitin, everybody is getting the right answer. 1500. Okay. So this type of question comes means you can easily do it. And now I'm going to the next question, number 20. Yeah. In a step-up transformer, the turn ratio is 1:2. 1:2 is the turn ratio. A Lagrange cell of EMF 1.5 volt is connected across the primary. The voltage developed in the secondary would be. So input voltage is given as 1.5. Turns ratio is given. They are asking what is the secondary voltage. I am not going to solve this question. I am waiting for your answers. Please comment. Take your time. Yes, Nitin is saying it is option A. Dhruvil is saying option A. Others also, please comment your answers. Kirti is saying it's option B. Reshma is saying again it's A. Sriram is also saying it's option A. Yes, all are commenting it's option A, but my dear children, the answer is option D, 0. Why, right? It is a cell. Lagrange cell is a chemical cell. It is a DC source. Please note that you can't change DC volt by using a transformer because there won't be any change in flux. So as an input, if you are connecting a battery, any type of chemical cell, since the voltage remain constant, there won't be any induced EMF in the secondary, which means the output will be 0 in this case. So when you're seeing these type of question, please don't be excited and go with the calculation, because I know if you're doing using the formula, you'll get some answer. It is there in the option. So please be careful. The answer is 0. I think it's clear. Going to the next question, number 21. Look at this. In LR circuit, the inductive reactance is equal to the resistance. Inductive reactance is equal to the resistance R of the circuit. An EMF of E equal to E0 cos omega t is applied to the circuit. The power consumed in the circuit. So question is direct only. We have to find what? The power consumed. Power consumed means it is average power only. So let's go to the formula. Listen. P average. What is the formula for P average? V RMS I RMS into cos phi. This is the formula for what? Average power. Now in this question, the important information is inductive reactance is equal to the resistance. So you know that inductive reactance means what? L omega. That L omega is equal to R. So their values are equal. Then what is the power consumption? So you can write it. VRMS. What is VRMS? Here it is given as E equal to E0 cos omega t. So VRMS is V0 by root 2. So of course we can write VRMS is E0 by root 2. Into IRMS. What is IRMS? IRMS is, you can write I equal to E by, in a AC circuit, instead of R we have to say impedance. So I equal to E by Z. So of course I RMS is equal to what? E RMS by Z. So in the next step I am writing E RMS by Z, impedance, into cos phi. Cos phi, what is the formula for cos phi? Cos phi is R by Z. R by Z. Okay, so let's substitute E naught by root 2. E RMS is again E naught by root 2. Into we get R by Z into Z is Z square. Okay, so E naught square, E naught into E naught is E naught square, root 2 into root 2 is 2, into R by Z square. Now we have to find the value of Z. How can we find? Z is equal to, it is an LR circuit. So Z is root of R square plus what? L omega the whole square. This is impedance value. But it is given that L omega is equal to R. So what we get? Root of R square plus R square. R square plus R square, of course it will be root 2 R. This is Z, but what we need Z square. So of course Z square is equal to what? 2R square. 2R squared. Okay, now you can substitute. Therefore P average is equal to, what will be the result? E naught square by 2 is already there. R is there, divided by 2R square. 2R square. 1 R will be cancelled. Look at the result. It is E naught square by what? 4R. E naught square by 4R. How many of you? Anybody? No. Please not. It's a tricky question. So there are some steps. More steps are there. So please be careful. Don't make any mistake. So we are starting from the basic formula only. P average is equal to V RMS I RMS cos phi. And we are finding power factor separately, impedance separately, and finally we are reaching the answer. It's option C, E naught square by 4R. Okay, so next question, question number 22. Very simple question. In a pure inductive circuit, current, please quickly, who is leading, who is lagging, you know that very well. In a pure inductive circuit, current, is it leading or lagging? Yes, very good. Right answer. All are commenting the right answer only. It is option A. Current is lagging behind the EMF by a phase angle of pi by 2. Very simple question. Yes, I'm going to the next question number 23. A current I equal to I naught sine omega t minus pi by 2 flows in an AC circuit. If potential of E is equal to E naught sine omega t has been applied, then the power consumption P in the circuit will be. Can you please answer it quickly? Power consumption, please note that current I equal to I naught sine omega t minus pi by 2 and EMF E is equal to E naught sine omega t. What will be the power consumption? Quick. Check the phase difference. One is current is minus pi by 2 is there. That one is sine omega t only, which means phase angle is equal to 90 degree, pi by 2. You can see that the current is lagging by pi by 2. Yes, very good students. If pi by 2 means power factor, cos phi will be 0. So average power will be 0 in this case. Yes, very good. Right answer. It is option D. The power will be 0. So power is another important topic from this chapter. So please study the formula for power. I am going to the next question number 24. Check this. If the adjoining figure, a series LCR circuit is connected to a variable frequency 200 volt source, L is equal to 5 Henry, C is equal to 80 microfarad and R is equal to 40 ohm, then the source frequency which drive the circuit at resonance. Source frequency which drive the circuit at resonance means, my dear students, it is nothing but the resonance frequency. Directly you can use the formula. Nu is equal to 1 by 2 pi root LC. This is the formula for what? Resonance frequency. You can substitute it 1 by 2 pi root of L. L is given as 5 Henry only, so no need to make any change. It is in SI unit. C, what is C? 80 micro. So 80 into 10 to the power minus 6. So which is equal to 1 by 2 pi into root of 400 into 10 to the power minus 6. Calculate it quickly. So which is equal to 1 by 2 pi into square root of 400 is 20 into 10 to the power minus 3 will come, that I am taking to the numerator, so it will become 10 to the power 3. Okay, so what we get, 10 to the power 3 means 1000 divided by 40 pi. Okay, so 100 by 4 pi, which is 25 by pi hertz. That is our right answer, 25 by pi. It's option B. Very good. Option B, 25 by pi. Okay. Easy question. We are just directly finding resonance frequency. Question number 25. A transformer has an efficiency. Look, it's a different type of question. A transformer has an efficiency of 80%. It is connected to a power input of 5 kilowatt at 200 volt. If the secondary voltage is 250, the primary and secondary currents are respectively. Look, it is connected to a power input. So P input input power is given as 5 kilo. 5 kilo means you know that it is 5000 watt. And V primary, it's given 200 volt. They are asking primary and secondary currents are respectively. So we have to find primary current and secondary current. So primary current, it is easy. You know that power is voltage into current. So P input is equal to what? VP into IP. Then IP is equal to P in by VP. P input is 5000 divided by 200. 50 by 2. 25 ampere is IP. 25 ampere is the primary current. We got it. IP is 25 ampere. But again, the problem is there are two options with 25 ampere. So we have to find secondary current as well. For that, we can find P out. Efficiency is given as 80%. That means output power will be 80% of input power. 80% means 80 by 100 of input power. What is input power? 5000. This is the input power. Okay, so what will be the answer? 4000 watt. This is output power. They are asking us to find the secondary current. So again we can use the same idea. IS, secondary current, will be P out by Vs, secondary voltage. What is P out? 4000. Secondary voltage is given as 250. Okay, so 400 by 25, it will be 16 ampere. I got the answer. Yes. Which option? Option C. Fahad, right answer. 25 ampere the primary current and 16 ampere the secondary current. Secondary current is 16 ampere. Okay. So I think it is also very clear. So the difference between this question and the previous transformer question is, you can see that here the output power is not equal to input power. Efficiency is 80%, which means there is a loss of 20%. Okay. Now the next question, number 26. An alternating voltage 220 volt 50 hertz frequency is applied across a capacitor of capacitance 2 microfarad. The impedance of the circuit is only a capacitor circuit. There is no other element like resistor, inductor, nothing is there. Only capacitor. Capacitance value is given. Impedance. Impedance means reactance only. So we have to find the XC value. XC is what? 1 by C omega. 1 by C omega. So we can substitute 1 by, what is C value? 2 micro. So 2 into 10 to the power minus 6. And omega is, frequency is given as 50 hertz. So omega is 2 pi nu, you know that. 2 pi into nu. So 2 pi into 50. 100 pi. 100 pi. Okay, so what will happen? 10 raised to minus 6 into 100 will be minus 4. It will go up. It will become 10 raised to 4 by 2 pi. Okay, 10 raised to 4 by 2 pi. So 10 raised to 4 is 10,000 by 2 is 5,000. Divide by what? Pi. What is the answer? It is option D, 5,000 by pi. 5,000 by pi. Yes, D is the right answer. Yes. So time is up. So I think you got a clear idea about the type of MCQs, the most probable MCQs from the chapter AC. Please practice these type of questions again and again. Okay, all the best for your preparations, and we can see with another topic on another day. Thank you very much. Take care. Bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.